Good evening, friends. Welcome back to the third class in integral calculus. We introduced ourselves to method of substitution in the types of integration techniques. Yesterday we defined three techniques. One is called method of substitution, and then method by utilizing partial fractions, and the integration by parts, the third method. We have been revising, or we have been doing the sums based on the very first method, that is called as substitution method. So we'll continue to understand this substitution method by doing some more sums from NCERT textbook. Let us go to the white screen. Yeah. So I told you the formulae from differentiation are very, very important for us because they will help us to apply wherever this integration work is going on. Like integration requires differentiation formulae thoroughly. So let us start the first sum again, where method of substitution, I'm putting the heading here. Out of the three methods, the first one we are revising now. Today we'll conclude this method of substitution. Let us see. Integral 2x sine of x square plus 1 dx. This is the sum given to us. Here, what we do, substitution we have to use. Because this is looking like two functions multiplying. 2x is there, sine x square plus 1 dx is there. So better we simplify this sum by utilizing the substitution method. Let us understand first. Put x square plus 1 is equal to t. Here, there you have a choice whether you can put 2x is equal to t or x square plus 1 is equal to t. But when the choice is given to you, you cannot just like that select any one of these, because by choosing wrongly the other one, sum will become more complicated. We should choose correctly, wisely, which one to be substituted as t. See, now I have taken x square plus 1 is equal to t. Then differentiate both sides. Differentiate both sides with respect to t. Then what happens? X square differentiation 2x, 1 differentiation is 0. 2x dx by dt we should write here. I'm writing because we are differentiating x. 2x dx by dt. Then plus 1 differentiation is constant, therefore 0. This side dt differentiation with respect to t1. So that means 2x dx is equal to dt. You cross multiply with 1. 2x dx will remain here, left side. Right hand side will get a dt. So now if you observe the given sum here, 2x sine x square plus 1 dx is there. So 2x dx you can write independently as dt. Sum becomes simpler now. So integral, I am writing now sine x square plus 1 into 2x dx. I just rewriting this word so that it will become easy to understand for you. Sine x square plus 1, now I can write sine t. 2x dx I can write dt. See, simplified became. What is integral sine x? You know very well, minus cos x. So this will become minus cos t plus c. So t you put back again x square plus 1. See the substitution how it helped now. You have to carefully select. One of the terms will become dt by selecting the other term as t. You should not select wrongly, and then even if you select, you will come to know by yourself. Suppose even if you take 2x dx is equal 2x is equal to t, 2 will become dt. Where is 2 here? 2 dt, not there. So by putting x square plus 1 is equal to t, your sum becomes simplified. Okay. Let us go to the next sum. Integral tan to the power of 4 root x to secant square root x whole thing divided by root x dx. See the sum here, tan to the power of 4 root x, secant square root x, root x. If you observe clearly, secant squared, you forget about root symbol now. Secant squared x, if you find, it means it is differentiation of tan x. Is it not? So if you take tan x as the t, your sum will become simpler. So we'll put tan root x as a t now. Instead of writing tan to the power of 4 root x as t, we will write only tan root x because here secant squared root x is there. So differentiate both sides with respect to t. So tan root x differentiation, secant squared root x differentiation 1 by 2 root x, x differentiation dx by dt, this side 1. So now secant square root x divided by root x you bring here, and dx also you write down. This 2 dt you send that side. 2 dt you send to the right hand side. All other terms remain here. Why I am writing all this? Secant squared root x dx by root x. So we are having almost same. Hope you are understanding. So in the place of this entire thing, you can write down 2 dt. In the place of tan 4th root x, what you can write? T to the power of 4. Because tan root x, tan to the power of 4 root x is there. This we can write as tan root x whole to the power of 4. Now tan root x we are calling as t. So t to the power of 4 you can write. So therefore your given sum will become t to the power of 4 2 dt. Because secant squared root x by root x dx is now becoming 2 dt. 2 you send outside, t to the power of 4 dt. This will become 2 into t to the power of 5 by 5. As power formula again, 4 plus 1 by 4 plus 1 plus c. So what is t now? Tan root x. Tan to the power of 5 root x divided by 5 plus c. So understood, no? Very good sum. Then next sum. Integral tan inverse x, sorry, integral dx, integral dx by integral sine inverse, sine of tan inverse x divided by 1 plus x square dx. This is the sum. Integral sine tan inverse x by 1 plus x square dx. By now, I think you can easily grasp the fundamental. What to substitute? No, tan inverse x. You know differentiation. Differentiating both sides with respect to t. Then you will get 1 by 1 plus x square. Tan inverse x differentiation 1 by 1 plus x square dx by dt is equal to 1 because t differentiation is 1. So we are having now dx by 1 plus x square this side, dt you send that side. I separated now. So dx by 1 plus x square in the sum it is there, which can be replaced by dt. So our sum will become now sine of t, then dt over now sine tan inverse x. Tan inverse x place you can write t. So sine t dx by 1 plus x square is dt. So minus cos t plus c minus cos of t stands for tan inverse x. Hope you are understanding this. Next. Now we will do some important integrals. Again, all are like this only, based on your substitutions and power formulas. I'm writing heading also. Some important integrals. These we have to do. Examination point of view also important. Very first one. Integral tan x dx should be shown as log of secant x. This sum we'll see now how to do. So integral tan x dx. Here, what we do, tan x you write as sin x divided by cos x. Okay. Now you take the substitution. If you put cos x is equal to t, you know minus sin x dx will become dt, or sin x dx will become minus dt. So that only we should write. Put cos x is equal to t. We should not write put sin x is equal to t. If this cos x were on the top, that could have worked out. But now no, cos x is in the denominator. So therefore we cannot write put sin x is equal to t. Cos x you can write. Put cos x is equal to t. So differentiating both sides with respect to t. Cos x differentiation minus sin x. X differentiation dx by dt is equal to 1. Minus sin x dx is equal to dt, or sin x dx is equal to minus dt. This minus sign went that side. So now our sum is ready. Sin x dx numerator part, we can substitute minus dt divided by t. So what we wrote, integral tan x dx, we have written as integral sin x dx by cos x. Now we'll substitute here minus dt by t. So 1 by t, that's called log t, plus c minus log. Now t stands for cos x. So minus sign, you write like this. Your logarithmic formulas, 8th or 7th, I remember. Log x to the power of n is called n log x. This formula we used here. Log cos x whole to the power of minus 1 minus log cos x. Okay. So this becomes now log of cos x whole to the power of minus 1 means write down 1 by cos x. So this will become log secant x. 1 by cos you know. Okay. So this is a technique. Here the substitution method we used. That's what I wanted to stress now. Second one. Integral cot x we have to prove as log of sin x. Correct? This we have to derive. So let us see how to do the same way like previous. So integral cot x is equal to integral cot x dx integral cos x by sin x. So put sin x is equal to t. Now differentiate with respect to t. Then sin x differentiation cos x dx by dt is equal to 1. So therefore cos x dx will become dt. So now you come back to your sum. Integral cos x dx by sin x we are having on the top. This will become dt by t. Integral dt by t is nothing but log t. So it is called log of sin x. Cut t is called for you sin x. Okay. So next one is integral cosecant x dx. Integral cosecant x dx. For this, what we have to show answer? We have to show minus log is equal to, we have to show minus log or log cosecant x minus cot x. Log cosecant x minus cot x. This one we have to prove. So how do we prove? Integral cosecant x dx. This is a special technique is there. You multiply and divide by cosecant x plus cot x. This is, you have to remember this. Multiply and divide by like this. Right? Now put cosecant x plus cot x is equal to t. Put cosecant x plus cot x is equal to t. Now differentiate both sides. Cosecant x differentiation minus cosecant x cot x minus cosecant x cot x plus cot x differentiation minus cosecant square x. And x differentiation dx by dt. Here t differentiation 1. Take out minus cosecant x common. You are left with now cot x plus cosecant x dx by dt, or minus cosecant x. Just you rearrange, because here top you observe here cosecant x into cosecant x plus cot x you are having. You can write even, doesn't matter, like this also. Dx here dt. This dt cross multiply. So now this minus sign you write over there. So now whatever numerator part you are having on the top matches to this. Matches exactly to minus dt. So you observe now the sum cosecant x into cosecant x plus cot x divided by cosecant x plus cot x. This is what we are having. So this entire numerator can be replaced by minus dt. This denominator part will become t. So integral cosecant x into cosecant x plus cot x divided by cosecant x plus cot x. This is what we are having. So this one I'll write now minus dt divided by t. This becomes minus log t plus c. So minus log t is what? Cosecant x plus cot x plus c. So now minus sign you can send to the top. That's what we are trying to do, or you can leave it here. It's not going to do any harm for us. I will leave it here. Don't worry. You can leave it here. Simply it will become unnecessary simplifications not required. You can do further so much, but not required. Okay. If they ask us to show a specific thing, like that time we'll see what any proof is required to be done. They asked like this. So what we have to do here, denominator and numerator. Cosecant x plus cot x divided by 1 you have to imagine. Then minus log cosecant x plus cot x. This 1 from trigonometric identity, you can write on cosecant squared x minus cot squared x. That is a trigonometric identity is there. 1 plus cot square x is equal to cosecant square x. So bring this cot square x this side. Cosecant square x minus cot square x. So 1 will remain. That's why this 1 was written like that. Okay. Cot square x. Now this one x a square minus b square formula in the denominator. So minus log cosecant x plus cot x whole thing divided by cosecant x plus cot x a plus b into a minus b. I'll write clearly this so that you will understand it. Cosecant x plus cot x, cosecant x minus cot x. See this, a plus b, this a plus b, a minus b, this formula. This and this cancel. So now what are we left with? Minus log 1 over cosecant x minus cot x. This can be written as minus log, this entire thing bring to the numerator, cosecant x minus cot x whole to the power of minus 1. Now logarithmic formula, what we learned in the previous sum. This minus will go to the top here, make it plus. So log cosecant x minus cot x plus c. Okay. So some special techniques we have to use and then do the sums. Okay. Next. Integral sin cube x cos square x dx. In this sum also special technique we use. Sin x you split into sin cube x you split into sin x into sin square x. This is cos square x dx. Then sin x as it is, write down. Sin square x, you remember no 1 minus cos square x. I don't want to write on the right again. You must be knowing this. Cos square x dx. Put cos x is equal to t now. Now if you differentiate, minus sin x dx by dt is equal to 1. That means minus sin x dx is equal to dt, or sin x dx will become minus dt. So we'll substitute here. Sin x dx, 1 minus cos square x will become 1 minus t square. Then this is cos square x is t square minus dt. So this sum I am just rearranging so that you will not get confused. Cos square x into sin x dx. So now this sin x dx minus dt, cos square x is t square, 1 minus cos square is 1 minus t square. You multiply inside, minus you bring outside. So now you split this integration to put on square bracket, minus is common. T to the power of 4 dt, t square minus t to the power of 4. So minus t square's integration t cube by 3. T to the power of 4 means t to the power of 5 by 5. So minus if you send inside, t to the power of 5 by 5, minus into minus will become plus. That's why I wrote first. This will become minus, so it goes this side. This entire thing will become now cos to the power of 5. Correct? No, cos x only t. So t means cos x back you substitute. Cos cube x by 3 plus c. Okay. These are all simple sums. So don't get worried. Keep doing the sums at home. Regularly practice them. Any doubts are there, you just leave in the columns. And then I will conclude this here. I will try to touch upon method of substitution. Before that, I think some special integrals are there. Some different forms are there, like 1 by x square minus a square, like that. Those things we'll try to do tomorrow or in the next video class. And until then, you keep practicing all the sums what we did so far. Thank you.